All right, welcome back. So now that we've defined the derivative, and what is a derivative again? It's the slope of the tangent line. Very good. Yay, y'all got an A+. All right. Anyway, so now that we've defined it, let's go ahead and actually find the derivative of each function. So let's look at part A. So g of x is equal to the square root of pi over ln of 2 times x plus 7. So again, the derivative, that's the slope of the tangent line. Well, what kind of a function is this? Well, that's linear. It has a really weird slope, but it's still a linear function. So that means g prime, or the derivative, is going to have the same slope as the original function, which is just the square root of pi over the ln of 2, since g is linear. Now that you can only do that with a linear function. If it's not, then you're out of luck and you got to actually go through that whole limit shebang. So that's what we're going to have to do in part B. So the derivative is going to be the limit definition. So the limit as h approaches 0 of all that f of x plus h, da, 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 da. Okay, so the first part is that f of x plus h. So x plus h to the third minus 2 times x plus h, and then minus the original function. So x to the third minus 2x all over h. Okay, so let's go ahead and expand this sucker out. So x plus h to the third would be x to the third plus 3x squared h plus 3xh squared plus h to the third. And if you're going, oh my gosh, how did he do that fast? Well, one, I'm really practiced at this. I've been doing it for a while. And two, you can use Pascal's triangle to expand all this, big quantities out. Okay, so then let's distribute the negative 2. So negative 2x minus 2h, distribute the negative. And even though it looks ugly, a lot of them do. They expand out to these massive quantities, but then you're going to have a lot of stuff that starts to cancel. So like your x cubes are gone, the 2 x's are gone, and then everything else has an h in it, which is kind of nice. Because now you can cancel an h out from every term. So 3x squared plus 3xh plus h squared minus 2. And again, your goal is to get that bottom h to cancel out. So if it's not, what I would do is go back and check first to see if you distributed that negative across the entire function. Probably 9 out of 10 times, if students aren't getting this to work out the way they want it to, it's because of that. So when they did that minus f of x part, they didn't distribute the negative, and so they didn't get things to cancel out, and not everything had an h in it, and they were like, oh gosh, now I'm screwed. And it's like, well, if you didn't do anything else, yes, you are. But if you go back and check it, did the negative get distributed? And if you did do that, then I would just check the other algebra. There's a mistake in there somewhere, you just got to find it. Because it's not going to be a D and E. They will exist. All right, So now you can plug in the 0 for x, or sorry, for h, and it's going to knock out this term and this term, and you're left with 3x squared minus 2. And that's all they wanted you to do. They just wanted you to find the derivative of the function. Okay, so let's move on to example 3. Find an equation of the tangent line to the graph of f and then graph it. So let's do part B. Part A, you can look at the notes for that one. But let's do one with part B. I don't think we've done one like this yet. All right, so the derivative of g, we got to find that first, because that will give us the slope of the tangent line. So your x gets replaced with x plus h, and then minus the original function. All of that over h. Now there are a couple of ways you can go about simplifying this. What some people do is they get a common denominator on top, combine everything, then multiply by the reciprocal of the denominator, and then they go from there and call it a day, which is totally fine. You can totally do that. Personally, what I do is I use the common denominator to get rid of all the little fractions. So the common denominator is still x plus h minus 1 times x minus 1, and I'm going to multiply that to the top and also the bottom, because that's going to clear out these little fractions on top, and so then I just have one numerator and one denominator, and that's it. So all this green stuff gets distributed to that first fraction. So those two quantities cancel out, and you're left with x minus 1 minus the second fraction. You're left with the x plus h minus 1. And then in the denominator, you still have all of this. Like nothing cancels out of that bottom part, which is fine. At least not yet. Okay, so just distribute. Keep the denominator the same. And if you notice, a lot of stuff in the numerator cancels out. Your x's are gone, the 1's are gone. And so you're left with the negative h, which can cancel out the h in the denominator. So you have a negative 1 all over x plus h minus 1 times x minus 1. And now you can finally plug in that 0 for h. So you get negative 1 over x minus 1 squared. So there's your derivative, but we got to find the actual equation of the tangent line. So this right here, that's the derivative, which is the slope of the tangent line. But I want the actual slope at this point. So plug in the x value of the point, the 2, into your derivative, and that's going to give you negative 1s, and that is the slope of the actual tangent line. So now you have the point of the tangent line, you have the slope of the tangent line. So use point slope formula. Oops. So y minus y1 equals m times x minus x1. So the y value of the point is a 1. Your slope is negative 1. Your x value is 2. Solve for y. So y equals negative x plus 3. So that is the equation of your tangent line. Then the last part, graph the function and its tangent line. So I'm going to do it over here just because I have more room. So 1 over x minus 1 has that vertical asymptote at 1, horizontal at 0. So it's going like that, and like that. And then your tangent line at the point 2, 1, so about right there. Tangent line is going to go just like that. Okay, so let's stop the video from here and we're going to get into some concept stuff in the next one.